All right. Let me give an informal greeting. Good morning to Taiwan uh, participants, and good evening. And for U.S. American students, faculty, and friends. And I see that there's a camera to the main hall. I think that I also see uh, Professor Pan is hosting this conference in person. I think this meeting in person in National Chongqing University. And this is 8:57 now. Give me a couple of more minutes, then we will, uh, Dr. Pan and I will officially start. And to give a little more information, so this is co-hosted in University of Texas at Dallas and the National Chongqing University in Taichung, Taiwan. For those who are new to Taiwan, Taichung is the city located almost exactly the middle of the island state. And so most believe that that is the best spot for weather, for food, for transportation, and a lot of nice people. And so that is a place I highly recommend you to visit if you in future you want to study or do research or attend a conference. And that is a really beautiful place and a great place. And if you have not visited Taiwan, this is a must go, must do in a bucket list. And all right, now I'm planning to see some more. Hello, Dr. Pan, is your mic live yet? We have Dr. Busby and board. I think I will get started in maybe 1 minute. Let me check if Peter is on the mic yet. Right.
So, Carl, can you hear me?
I can hear you well. You have a
Okay.
little bit of echo though.
I know, I know. Let me make sure that this. Wow, what is that? What is a
But
cutie
more
there?
students, but more students from Utah.
More
Eth-
children.
Ethan, is that a student or is a faculty?
Uh, well, I was faculty. That's my cat jumped up on the table. I've got my pets really. I will talk about this too. My pets really are attached to me. So like my dog is right here by my feet, and my cat wants to be right on top of me all the time. So I'll try to keep them off the table. But
No, that's okay. I'm sure she or he must be an LLM expert. Excuse me. Must be an AI expert here. Getting close to you, say close to you, so much AI.
Huh?
All right. And Peter, if you're okay, then I will start in 1 minute.
Okay. As you somehow this is an echo, I cannot fix it.
Okay, I'll leave it. Just let me know. Just cue me. Give me a cue and then and you're ready. All right.
Okay,
Take your time.
I'll try to fix it in 30 seconds.
Don't worry. And
All right. All right, Carl.
yes. Yes.
Yeah, please proceed.
All right. Welcome. Okay. Good morning to our Taiwan friends and good evening to our American friends or either one. And for those who are from other corners of the world, welcome to the Data Analytics Colloquium, October 30th, 2025. And my name is Carl Ho, and my co-host is Professor Peter Pan. So we are really excited because tonight we have, or today we have a really special guest and introducing us to a new world of data or AI methods. And Dr. Eden Busby is going to give a talk. Title of the talk is Artificial Intelligence Using LLM as a Tool for Inference in Social and Political Science. And maybe let me introduce Peter. And Peter, is it okay you give a few words to introduce the colloquium?
Mm-hmm. All right. Good morning, good evening. So we have three cities right here, right? We have Taichung, we have Dallas, and then we also have some in Utah, right? So then there were 3 places in 3 different time zones, and that's quite an interesting thing happening here. Let me greet you first and give you a brief introduction of this DAC, Data Analytics Colloquium. I think this might be the 5th season. Yeah, the 5th year. Carl and I have started to work on this one. And this program, or actually this project is initiative is sponsored by National Zhongxin University in Taiwan, and then also by UTD. And we try to convene the international scholars and data scientists, so online seminars and workshops. So today, obviously, our audience today, you can experience what we have been doing so far, and then let me welcome you. And also, I hope that today that's a feast for us. And then I trust that Ethan can share with us, because just judging from the title, and then I'm so excited to hear more about it. And let's wait and see. So, Carl.
All right. Okay. Let me briefly introduce our honor speaker, and I'm really excited to have Professor Busby to give a talk, and I talk about the title of the talk already. And give me some time to introduce to you Dr. Busby and Professor Eden Busby, and he's assistant professor in Brigham Young University, generally called BYU, and most people know BYU. And Dr. Busby, and we know I know him earlier this year in Southern. He was convening a conference within a conference in Southern Political Science Association, and that is a specialized a group of panels on LLM and AI applications. And so most people, I think I would not repeat the bios on the already listed on the website for this webinar, but I particularly want to point to your attention Dr. Busby's paper published in Political Analysis 2023, and the title of the paper is Out of One: Many Using Language Models to Simulate Human Samples. So I talk to my students, and you're in my class, and you know that I use this paper a lot, and to highlight the application of AI synthetic data for social science and political science research. And every time I said, oh, this paper is well cited, and 700, 800, and 900 within 2 years. So as of now, it has a citation 999. I think it's pushing to 1,000 citations. I talked to Ethan, and you really break a lot of records. And but this is other than that, is a really interesting paper, and I'm going to give you the link and on the chat box. And then please, if you have a chance, take a look at it. I think it's really inspiring and inspirational paper. And without further ado, let me introduce Dr. Eden Busby, and let him come to our floor. Okay. Dr. Busby.
Great, thank you, Carl. Thank you, Peter. I'm very grateful to be here. I'm flattered that you want to hear from me. And I'll share my screen and talk so you can see some of my materials for today.
Sure. Yeah.
And I have some thoughts prepared for all of us, but as we go along, you may have other questions and other thoughts, things you want to ask. I'm open to talking about any part of my work, of our work, that would be of interest to you. So I'll give you some tidbits about what we're working on, as well as the general talk. And again, I'm really open in the discussion part, especially to have as much of a conversation about these things as you would like. So, but The title of the talk today, as Carl said, is called Artificial Intelligence. And what it represents is some of the thinking of our team, our research team, who I'll introduce you to a little bit in a minute, like about what are the ways that we can use language models better as social scientists or computational scientists or data scientists. Like, how can we fit these tools into the scientific method, and how do we use them more reliably? Again, it represents quite a bit of time that we spent thinking about some of our advice to other people working in this space. And we feel, again, very grateful that we've had the success as a team as we've had, but we've had an opportunity to be involved in this about as long as anybody else using these tools in political and social science. I'm not going to claim more than anybody else. I'm sure there are others who've been doing it more than us, but we started working on this in about the summer of well, probably the winter of 2021, I think, is when we began working with this. And so, again, we spent some time thinking about it. I want to share some of the thoughts with you today about that. So the team that, and really this, I put these pictures up and introduce you to these people because this is not my enterprise. This is not my project. This is our project, our team. We have a team of computer and political scientists, most of whom are at Brigham Young University. Dr. Argyle, Lisa Argyle, is now at Purdue University. But this really is a collaborative effort of our team, and really represents the work that we've done, a combination of computer and political science. And some of the guiding questions, before we get into the specifics of the talk, I want to give you some previews of the work that we do and how we think about this, and then we'll dive into more specifics for the presentation for today. If I had to summarize the orientation or the objectives of our team with respect to language models and AI, would be the following. We like to ask and really dive into the question of, how do large language models help us be better social scientists? How can we use them to be better social scientists? And how can we use large language models to improve? I put democratic in parentheses here because the political scientists on our team are really focused on the quality of democracy, the strength of democratic discourse, those types of things. But we could just talk about society broadly. Again, our focus is more on the democratic component of society. But we like to think about how can we use language models to improve society rather than focusing simply on the negative potential impacts. And there are many of those. We're not downplaying or ignoring those, but we like to focus on what can we do that will be socially or democratically productive. The work that we produced, some examples of that work, as Carl mentioned, the Out of One mini paper was our first paper, which we sort of had the good luck to publish just a month or so before ChatGPT was released, and that really accelerated, I think, the citation count as people became very familiar. And the sort of anecdote I like to tell people about that paper is when we were trying to publish it for the first time, we couldn't get anybody to care about language models. And we were really interacting with a lot of people who didn't really know what they were. And obviously, I think the landscape in that sense has changed dramatically. Some of our other projects, we have a paper in the Proceedings of the National Academy of the Sciences. It's called Leveraging AI for Democratic Discourse, about using it as an intervention to improve political discussions. A more technical paper in a sociological methods journal called Balancing Large Language Model Alignment and Algorithmic Fidelity. That has a lot to do with silicon sampling, thinking about different models and how they're constructed. And then another publication this year about testing theories of political persuasion using AI. How can AI help us to do things and study theories that are important to the social sciences but difficult to study? That's sort of what those are about. And again, if you have specific questions about those, I'd be happy to discuss them, especially with the time we have together to talk. Some of our current directions, so these are the things that are either under review or we're hoping to have under review soon, have to do with what language models do when we ask them to micro-target specific individuals. In the realm of persuasion, there's a lot of interest and sometimes concern about how language models facilitate micro-targeting, customized persuasion. So what precisely do they do when we ask them to do those things? We also have another paper about what role that gender plays in political persuasion, and using language models as a way to isolate different elements of gender, layering on top of language models voice-based AI tools so people have voice conversations with AI agents that we've developed. And then other questions about under what conditions do language models reliably simulate randomized experiments? How can we use AI tools to help people develop democratic skills and other things too? We have a very active group here, and these are just some of the directions we're going. I present those to you in case any of those topics are of interest to you and you want to discuss them as we talk or later. This is sort of the several directions that our team is going in. In terms of the more narrow talk today, what I want to talk with you a little bit about is the ways that language models, or how we can use them in a way that facilitates scientific inference. And I'll talk a little bit more about that and what I mean by that. And suggestions that we have as a team for using them in a way that really pushes science forward. As part of that, I'll talk a little bit about how do we deal with failures in language models, what does success mean, and we'll end with some pretty practical recommendations. This is the talk itself is drawn from a paper we published this year that was a commentary to social scientists, and so it's perhaps more pragmatic than many of my papers tend to be about, like, well, what should you do and how can you do this well? And I hope at least some of that is helpful to you. In general, at the highest level, what I'm going to argue, and we can have a discussion and debate about this, but what I'm going to argue is that language models are extremely powerful and versatile. You probably are aware of that already. But their value to science depends on how much we use them to use scientific inferences, rather than just to do new things or things that are maybe attractive or shiny or catchy. And so I'm going to walk systematically through some thoughts about what does it mean to draw inferences and some recommendations. And the goal of this discussion for me is to be broad and flexible so that you can see how this will apply in the specific place where you work. There will be some pretty specific recommendations, but others where I talk in more general terms to say, this is a place where you should think about how this applies in the space where you work. As a sort of an initial caveat to all of this assumes a positivist approach to science, and that we're rooted and interested in the practices of transparency and replicability. I don't say that because that's the only way to understand the world, or perhaps even the best way, but it is a prominent way and the dominant way in empirical social science. And so we're sort of rooted in that perspective. I say that just in case some of you come from a different background, and that's sort of where I'll begin, and sort of where this is all rooted. To begin then, we start with the idea of, well, what can we, how well or in what ways can we use language models to make scientific inferences? And to illustrate what I mean by this more concretely, this is a depiction of the scientific process. And there's different ways to do it, and we can discuss about perhaps the best way. But this is a way to represent the scientific process. The basic question that we ask here is, how do large language models fit into one or more places in this process? And we could think about them fitting into no parts of this process. We could think about them fitting into many parts of this process. But how can we integrate them as a part of science, and sort of use the skills and lessons that are a part of established scientific thinking to help us to use them in a way that's productive for the social sciences and again, the scientific community more broadly. And one of the analogies that we have started to think about is that, large language models, they're not just machine learning models. They're sort of at their core based on a lot of machine learning principles, but their varied use and applications are much broader than typical, even machine learning tools that social scientists use. And as we wrestled with to think about, well, what is another comparable thing that's happened to the scientific community that seems similar in this dynamics? The closest analogy we could draw was the internet and the advent of the internet. And I'm now old enough to remember a time when people didn't use the internet the way that they do now. But the advent of the internet for the scientific academic community had a number of profound implications, and a number of implications for how we thought about research and how we did science. For example, the advent of the internet really changed the way people consumed research and information, and their access and ability to do those things. And it also changed habits that people had in terms of how they learned and how students thought and accessed materials. It also shifted the way that people wrote, think, and disseminated knowledge more broadly, and was a different way for people to interact with each other, both in a social and professional way. And it also really dramatically expanded the nature and availability of human subject research data. These are some things that we would argue the advent of the internet enabled the scientific community to do. And I've chosen these particular elements because we think that there are clear parallels on all of these things for language models. I'm not suggesting to you that language models are a new form of the internet. But what I'm saying is that just as the internet shaped all of these areas that involve science and scientific process, so too I think do language models have the capacity and the potential and are already being used in these different spaces. So I think there's a lot of potential to really touch a lot of parts of the scientific process and academic research and academic life. At the same time, I think anyone that's used language models knows that they can be fickle, and that's sort of play on words as part of the title. And just because a language model can do something today doesn't mean it will do it in the future. And the inverse of this is also true. Just because a language model cannot do something today doesn't mean it will not be able to do it in the future. So this puts us in a position, I think, where language models have a lot of potential to really reshape and influence the way we do science, but their stability is in question, so the right way to use them is often unclear, and there's lots of questions about them. And again, the central thesis that we make in this paper, and that our group has come to feel strongly about, is that large language models are good scientific tools if they help us to make better inferences. And again, I'll give you some concrete examples in a moment about that. But to the degree to which we don't use them to make good inferences, they're not helping us do science. They might help us do other things. They might help us create art, or they might help us develop some technological tool. But if they're not helping us make inferences, then they're not helping us do science. And I think a quote here by a prominent thinker, I think is helpful in thinking about this, that the science is built up with facts, just as a house is built with stones, but a collection of facts is no more a science than a heap of stones is a house. And so again, we apply this way of thinking to language models. And so I'll give you an example about this. I mean, a fact we might observe from a language model is that given a particular set of settings and a prompt, a language model will generate a particular response. This is going to be, that doesn't probably seem too profound to you. If you've thought about or even played around with language models, you know you give it a set of instructions and it returns a response. But the question in terms of using it as science is, what inferences can we then draw on the basis of that thing, of that fact, or that outcome? Does the performance by the language model constitute a success or failure of the language model? And whether or not it does constitute a success or failure is related and then connected to the inferences that we can draw from it. With this way of thinking with language models, we suggest to everybody working with language models, I mean, the very, very first thing they need to decide, or they need to make clear, is what is the thing that they would like to make inferences about. And there are lots of possible options. And I'll go through some concrete examples of this to make this clear, but we could be trying to make inferences about people's behavior. We could be trying to make inferences about some larger theoretical concept. We could be trying to make inferences directly about language models themselves. And the thing that we're trying to make an inference about should guide the way we use language models as part of the scientific process. To give you an example of this, if we wanted to use language models for something like text annotation, which I think is a very prominent and growing use of language models in the social sciences, using it to code text for some idea, some concept, some important theme. What we need to know then is if it can identify that concept in a consistent and reliable way, and the inference would be valid if the measurement of the concept that we get from a language model is reliable and valid according to a series of metrics that would be familiar to you if you are doing text annotation. On the other hand, if we want to use language models for something like silicon sampling or synthetic data, we need to know that the language model represents humans for both, for example, on both sides of a political spectrum, or that the relationship between variables that it's simulating are accurate. And that suggests a different standard and a different way of thinking about what success and failure is than text annotation. And finally, if we want instead to use a language model to interact directly with people, to act as some type of intervention or treatment or stimulus, then we want to know that the language model is doing the thing that we would like it to do conceptually or theoretically, so that it's deploying the treatment as we would have intended. And we would want to evaluate it in light of that objective, of that targeted inference. But again, that suggests a different set of things we should be concerned about than if we're doing annotation or again, silicon sampling or something else. In thinking about these types of inferences and conclusions, I think one thing that many of us, myself included, often have to wrestle with is what do we do when a language model doesn't seem to succeed at a task, whatever that task is, text annotation, silicon sampling, serving as a treatment or something else. What does it mean when the language model doesn't successfully do that thing? There is a balance, I think, for us here between over-interpreting failure and under-interpreting failure. And so what I mean by this, over and under-interpreting failure, sometimes we see that a particular language model with a particular prompt can't accomplish a task. And we then conclude from that no language model can do that, or that it's beyond the capacity of language models to do a thing. When in reality, we're sort of over-interpreting and over-generalizing a lower level failure to mean something in a larger way about an inference of, again, language models more generally or something along those lines. On the other hand, sometimes we might experience what we would call a higher level failure or a deeper failure of language models, and we might chalk it up to something more lower level, like perhaps bad prompts, when in reality, it might reflect a limitation in these technological tools. And so I thinking carefully about how do we rule out or how do we establish what kind of failure is occurring, I think is helpful when wanting to work and assess with language model failures. And so some things that we could conclude, again, let's imagine we have a language model and we ask it to perform a task. Let's say we ask it to annotate a set of texts for something like hate speech. So we have it code a bunch of text and we want to use it as a way to document hate speech. And imagine that we fail at that task, that it clearly does not document examples of hate speech that it should categorize as such and miscategorizes non-hate speech as hate speech. Well, some things that we could conclude from that, the highest level interpretation would be that no language model can code for hate speech. On the other hand, we could conclude from that, well, that the particular language model we're working with, maybe we're working with one of OpenAI models, or maybe we're working with a large llama model from Meta, and we could conclude that maybe this particular language model that we're working with can't do that thing. Another way we could interpret that same failure is we could say, well, this language model could do this thing, but it's been aligned or trained not to do the thing. So somehow the post development training that goes into the models is interfering with its ability to perform the task, in this case, categorizing hate speech. And then again, another possibility is we're just bad at interacting with the models. I call this poor information extraction, but maybe our prompts are bad. Or maybe there's some part of the way we're reading in the documents it's not set up properly to really leverage what's inside the language model. And so I use these different levels to give you an example of how the same instance of failure could mean a lot of different things. And there is not a sort of systematic overarching test that everybody agrees with about how to determine which of, again, these four things has occurred. And we suggest that in the face of a language model failing to do some task, something we'd like to make some inference or conclusion about, we need to be transparent about what we've attempted and publicly report when a language model can't do something. And that people working with language models should try to, again, to rule out as many of these things as they can. So again, perhaps if I'm concerned that this is maybe a feature of a particular language model, maybe I attempt that same task with a different language model. Or maybe if I'm worried about alignment, I work with a version of that language model that has been aligned differently to try and establish or do the best that we can to try to determine what type of failure we are experiencing. Is this local to our particular prompt with a particular language model, or does it represent something more fundamental? Again, we suggest that this is a more productive way of thinking about failure with language models, because often, and you may have encountered the same thing, you'll encounter some paper or somebody's experience with a language model, and they conclude that it's sort of entirely worthless because it can't perform a particular task at a particular time. And I think that that's probably an overly simplistic and not particularly scientific way of interacting with language models. At the same time, I think we also need to think carefully about how do we know if a language model has succeeded? What does it mean for a language model to succeed in a task? And how do we establish that in a rigorous, defensible, scientific way? And so, again, in some ways, this is just as important and just as difficult as thinking about failures. And success can be multifaceted and difficult to define. We might think it's a success, but perhaps some other scholar or researcher might disagree. Even similar tasks can have different markers of success. So, for example, depending on the place where you work, if you want to think about this text annotation example, maybe we focus in our own research tradition on something like intercoder reliability, but some other research tradition emphasizes some other statistic that we might get some different results from. To give you another more concrete example of this in the space that we have worked in about silicon sampling, there's a variety of perspectives on whether or not language models can do this well. And some of this, not all of this, but some of this comes down to having different metrics for success. So to give you an example of what I mean by this, in our paper, in our 2023 paper, that Carl mentioned, We focus on aggregate mean or aggregate relationship, and we find success there. On the other hand, others, like the Santerkar paper I reference here, they focus on proportions and means in subgroups rather than overall. Others, like another really important paper in political analysis, this Busby et al. Paper that came after ours, focus not just on means, but on variances. We talk about distributions of attitudes in silicon sampling and not just mean correspondence. Others talk about the correct predictions of specific individuals. Our 2025 paper, which I briefly mentioned at the start, focuses on giving valid responses and the structural components of how language models respond, rather than just correspondence with people. And with these different metrics, I think it would be easy to be very confused about can language models do this task, or do they succeed with this task, and what then counts as success. To further complicate this, and I promise I'll get more positive in a minute, I'm just sort of trying to lay out the problem. I'm not trying to be overly pessimistic. But to further complicate this, success is non-transitive, at least for now. And what I mean by non-transitive is that this is language models, they are different from other statistical machine learning tools, statistical machine learning tools. And it can be challenging to make a lot of assumptions about a model's capacity the way that we would if somebody developed, for example, a new method of factor analysis or some new econometric way of estimating something. And typically, the way that that would work in the social sciences is that someone would publish a methodological paper and establish that some method worked, and the rest of us would not need to continually reestablish that that method would work. We would accept it, we would cite that paper, and then that would be our sort of touchstone, if you will, for knowing that that method will work. Unfortunately, our experience with language models has been, because they're unstable and complex and in many ways not understandable in a fundamental level, we can't make those same kinds of assumptions. But just because in our 2023 paper we were successful at silicon sampling, I don't think that anybody should simply cite our paper and say, well, we can proceed and don't need to do any kind of validation or evaluation of success, but because Argyle et al. Found that we could do this in 2023. And I think that is a big challenge for establishing language model success. And further, success can be model dependent. The particular model you're working with, maybe you have a very, again, to come back to this example of text annotation, maybe you have a very nicely developed prompt for some of Google's Gemini models that really works well for coding for hate speech, but those prompts are unlikely to work without modification on some other language model, say a Claude model, or an OpenAI model, or a Quen model or something else. Right? And so success seems to be dependent, or at least to vary based on the specific model that you're working with. In the face of all of this, our recommendation is not, I mean, as you can probably imagine, we're big proponents of working with language models. So our recommendation is not simply to throw our hands up and say, well, we can't use this in a scientific way. And it is instead, our recommendation is that we should pre-register in some form, and I'll talk about some different ways to do this, bespoke or customized validation for our particular use of a particular language model. And that we should ask ourselves the following question: what would success look like for the particular task that we are asking our language model to do? And does our language model meet that standard? And I think embedded in this is the need to choose standards that are defensible in the discipline you work in, that draw from established methods and tools. But again, I think every application of a language model should ask itself this question. Say, well, what does success look like in our particular case? And does our particular language model meet that standard of success? And there's different ways to do this. I'm going to give you a couple of possibilities. But again, our objective here is not to definitively lay down the one process everybody must use, but instead to sort of give some general principles that we think apply in a range of settings and a range of fields. So for example, one way to do this would be to define some set of benchmarks and then pre-test the language model until it reaches that kind of benchmark. And then from there to pre-register both the benchmarks, the prompts, the specific language models. So to do a lot of this validation process before any kind of formal pre-registration or documentation about what our research plans are. And then again, pre-register those things and then conduct the study and do some additional validation after the study. So again, to use an example of text annotation, that same one I mentioned several times, and I'll give you a different example in a minute. But we might, for example, say, well, we have a set of benchmarks that will help us to know that the language model is reliably coding for hate speech in a set of documents. And we're going to work carefully with the prompts until we are happy with success. are happy with the level of success on those benchmarks. And then at that point, we're going to pre-register which benchmarks we use, the prompts that we have developed, where they came from, the specific language models we plan to use them with, and then we're going to run the study from there. And then afterwards provide some post-validation. So that's one way to do this sort of bespoke validation. A different way, and again, I'll talk through this and then describe with some examples what this might look like. A different way would be to define some benchmarks first, pre-register what those benchmarks are, and then determine what prompts and specifications meet those benchmarks, run the study, and provide some evidence afterwards that those benchmarks have been met. So we most often do this kind of, as opposed to the first. We most often do this when we're working with language models as sort of live methods of interacting with people. And we, again, typically will say, well, here's sort of what our standards for success will look like. We'll pre-register that process, and then we'll begin the study and do some pilot testing, a sort of validation of what we thought might work, or rethinking of what we thought might work and might not, and then run the study and give some post-study estimates of those same benchmarks afterwards. And I think whether or not these two, which of these two modes, or whether or not some other process of validation is suited to your method, will depend again on your answer to that question about what would success look like, and what are the benchmarks, and how will I know that this particular language model meets those benchmarks. In terms of what we do to sort of bring all of these different things together, these thoughts about success and these thoughts about failure. We have a set of recommendations about things that should be done before and after a study is conducted. And what I mean by this is, prior to a study, what we suggest everyone do, or what we suggest would be good or better for everyone to do, would be to define clearly what you want to make inferences about, to identify one or more standards of success, to pre-register some success benchmarks, and then after a study is done, to again restate or clearly report what that inferential target was. And I'll walk you through an example from some of our own work about this in a minute. But then provide some evidence of benchmarking, and then report detailed information about language models, which was used, what the prompts were, and also report not just on the sort of final iteration of the prompts, but our more exploratory efforts with language models so that others can learn from those experiences as well. So we're sort of working less on our own and more as part of a larger collaborative community. To give you an example about some of the ways that we do this, one of our published papers, the one that is about testing a political persuasion using language models, we had the context of that study was we used language models to craft different types of persuasive appeals to people and to tailor them in different ways depending on experimental conditions. But we had language models that were given different kinds of tasks. Some of them were asked to create just sort of vignettes or paragraphs that were persuasive. Others were asked to have interactive conversations with respondents, with human participants. And we also assigned some language models to talk about one topic in the United States. One of the topics was immigration. And in another topic was the regulation of education in K through 12, public school. So we had a number of things a number of validation benchmarks that we had in mind when we designed that study. For example, and this may seem sort of obvious or perhaps too obvious to be interesting, but we wanted to ensure that the language models were talking about different things when we assign them to talk about the different topics. We would want language models discussing immigration to bring up different ideas and different words and different concepts than if they were talking about education in classrooms. And so one of the things that we did in that particular setting is we used some different types of semantic embeddings, and we sort of outlined how we would do this in our own plans to make sure that the semantic content in those two different topic conditions was distinct. And again, that's a pretty low bar. We had other things we wanted to do as well to validate, but at a very basic level, we sort of said to ourselves all the time, the language model must perform this task, must perform this way for us to really have any confidence that they've done anything correctly. And so again, in that particular case, we sort of laid out what we would use to look for differences in content, and afterwards did those types of semantic embeddings and presented them along with our main findings. You can see them as part of that published paper, that testing theories of political persuasion paper. But again, another thing that we did was we expected and thought that the language models should speak in different ways when they were asked to have a conversation with the respondent, as opposed to when they were asked to simply craft a single sort of persuasive paragraph. And again, that's again perhaps not too surprising, but for us, we always want to ensure that what we think the language model can do is in fact the thing that it does. And that even these sort of simple things about, well, generally they seem to do okay with these types of format and structure and tone things. I am always very concerned about how well it will perform those functions. And so for those particular cases, we use things like semantic embeddings, and we use things like a qualitative review of some early conversations and early responses from the language model in something like a pilot test. And we reported on those things in our published paper. That's a very quick summary of one way that we applied this. There are, again, other ways to apply it, and I can talk in more detail about that study or the way that we did those things if that's of interest. You're also, you can refer to that paper as well if you want to look at some of those details. But regardless, I think, of how we're using language models, I think that the place where we ought to begin is to say, what is the thing we want to make inferences about? And then think very carefully and be very upfront about what our standards for success and failure will be. How we know, or how we reassured ourselves that we have met those standards. By way of sort of giving you a way to think about this and refer to this later, the things that I've said today are sort of a summary or expansion of this, as I say, this commentary piece that we discussed. I'm going to leave this on the screen for a minute so you can sort of go to that link if you want to go to the link, or you can scan that QR code if you want to scan that QR code. That's a link to the published version of this paper, of this commentary paper, that walks through this in a more formal way and that you can refer to. Again, it's published in Nature Computational Science as of this year, so it's a fairly new publication. But I think our objective with this is to try and encourage the scientific community, of which we ourselves are a part, and we recognize we have not always done these things as clearly as we would have liked, but to try and use ourselves, try and encourage ourselves to work with these language models in a way that's going to advance science more directly, or allow us to do better social science. I think for the purposes of the presentation, that's most of what I wanted to discuss for tonight. I'm happy to, again, we can have as much of a conversation as we want to after this. I'm happy to go into other details about our work. I'm happy to talk more about silicon sampling. I'm happy to talk more about our other uses besides silicon sampling. I also welcome and I'm happy to correspond with anyone that wants to talk about this offline, that may have questions or thoughts about their particular application. We're always happy. These are ways that you can contact me. Either my website or my email address. Either of those are good ways to get a hold of me. And I am happy to have conversations. We want to enable and facilitate good research of all types, even if it's very different than our own, even if it disagrees with our own, even if it's applied in different contexts than our own. Our lab here at BYU is very interested in hearing from other people and interacting with them and sharing our thoughts about their work. So if there's ways in which we can be helpful to a larger community of folks that work in as we're happy and anxious to do that. I think I'll pause here, maybe stop sharing my screen and go back to just sort of looking at you directly. I hope that with that timing was okay, Carl and Peter. That's sort of what I had planned in mind. But again, I'm here and I'm happy to talk as much as we want to about whatever questions are in people's minds. And I can bring up other examples. I can bring up some of the details about some of our studies if that of interest, or whatever I can do whatever I can share that would be helpful. I would love to talk about.
Perfect. Absolutely. I think, thank you. And actually, this is, you're giving us more opportunity, more time to do the Q&A there for some questions for you. That's perfect timing. And we have, I think we have the chat box open. We have also another feature called Q&A. If you have any questions, you want to follow along that like a thread and you can ask or post, and then I will to follow along with that. Now, Peter, and
yes,
maybe I can start with you if you have, or your students or your attendees on the side, if you have any questions to start. And
okay.
yeah, thank you very much. Thank you. Ethan also posted the link to the paper. I already downloaded and I'm using the QR code. Yeah, Peter?
Yeah, I'll just try to collect some questions first. So if you have any one question that you can start with, and then give me a few minutes to collect questions, and then I'll follow. Okay.
Sure, I have a ton.
But I do
limited
have
advantage
one.
of being a moderator.
Right. I think I do have one.
Yeah.
Probably that Ethan can touch
Oh,
upon.
okay.
Yeah. Just
Okay, sure.
Ethan,
Go ahead.
that you just share something about how the LLM can. Well, that's. I think one of the students has mentioned that. Could you touch upon some examples of how this LLM-based AI simulate? Because one of your papers talk more about that. Yeah, simulate human behavior in real life situations. Just give us some example. Maybe that can stimulate some questions too.
Yeah.
All right.
Yeah.
Some short examples.
Yes, I can give some examples of what we have done, and then some examples of where some other people are working that are sort of pushing some boundaries on this and how they're really trying to push and see exactly how much can we do. So our particular paper, the one that Carl mentioned and Carl linked to, is starts by saying, well, how well in the context of politics and political attitudes might language models represent those views? And so what we did in that particular case, at least one of the things, there's different empirical application in that paper. One of the things that we did was we took a set of survey data from the United States, from what's called the American National Election Study, and we took a series of background descriptions, or so imagine a series of observations of respondents in the data set. And we said, okay, we know that these people, these are their characteristics. We know how they voted or how they reported voting in 2016. And what happens, or how well does the language model do if we ask it to adopt those personas and then report who they voted for in 2016. So we withheld that information from the model. We didn't tell it who the person voted for, but said you are, for example, a white man in his 30s from Michigan who was sort of leaning towards the Democratic Party and was somewhat religious. In the 2016 election, did you vote for Hillary Clinton and Donald Trump, somebody else? Like, and then what we did was we compared we essentially treated it almost like a coding exercise or an accuracy exercise, and said how much did the simulations from the language models correspond or agree with the original human data. And in that particular case, we found extremely high levels of correspondence in the reporting of the votes between Republicans, Democrats, people living in different parts of the country, people from different racial or other socio-demographic groups. We did other applications too, when we looked at other points in time besides just 2016. But that is an example of what we did to try and again, the purpose of that paper was to try and establish, well, can language models do this thing? I think some of the ways people are using it that are perhaps more methodologically interesting are people trying to say, well, how can we use language models to do this type of simulation in the absence of some human data? So what I mean by that is in our particular application, we always had some kind of ground truth human data to compare to. And we wanted that for that paper because we wanted to establish that it was working well. And to know, it's hard to know how well it's representing people without knowing how those people would have responded. But in the end, if you can't ever get beyond needing comparable human data, the question quickly becomes, well, what is the language model providing that's of value? If you just always have to run another survey that's parallel to what you do with the language model, what is that really providing? I do think, though, that the folks working in this space are really trying to push the boundaries that can we use it to like do a set of pilot tests or preliminary wording of questionnaires, or as a superior method or a better method of things like data imputation. Maybe you have a series of surveys where at some waves you're missing questions by design or otherwise. Can you fill those things in with language models? And other people are using them to not represent sort of individuals' attitudes in the abstract, but trying to simulate things like conversations. Can we, for example, simulate how two people might talk to each other or how they might deliberate together to reach some decision? And again, there's even more applications in that space too, is really trying to push the boundaries of how much can we get from a language model that reflects human behavior attitudes. There's a lot of validation issues in that space, but that is some of the ways that that's where we started and where I see a bunch of people going from there. And if you want some more other you want some other specifics about that or more details about our study, we can certainly talk about them. But that's an example of what we do and what some other people have done with language models in that sense.
Okay, thank you. Yep. And then there seems that there are some questions on the chat box.
Yes,
Carl?
I think John has a question. John and I have been working on a project, but he has been using an SLM and as a local, and such as three GPT OSS or Mistral 7B. Have we tried any of those local? Then a local LLM try to target fine tuning for silicon sampling.
Yeah, we have done, especially in our 2025 paper in the sociological methods of research. We used not any of those particular open source local models. We used others, but we did use a set of them to try and work with to think about alignment and language model construction. And we, in our particular group, have not found a lot of success from fine tuning in particular. Again, I'll come back to the smaller local models, but the fine tuning I think has a lot of potential. We have typically found that well-developed or well-validated prompts can get us almost all the way that we need to do the task that we want to do. Fine tuning can come with some costs in addition to benefits. I think some of the costs are just computationally more intense. In addition, it is possible sometimes that language models, through the process of fine-tuning, lose other desirable characteristics. They may gain something that you want, but lose, again, other things that have been trained into them. Typically, computer scientists refer to that as catastrophic forgetting. It's not always present in every model, but some models do display that tendency. Thank you, Carl. That is the paper. Our general experience with smaller language models that are more locally hosted or hosted on some cluster that you have, the general experience that we have had with them is that the larger they are, the better they perform, and that comes with a lot of costs, right? I think the very, very small models you can run on your laptop, they tend to perform much worse than the larger ones. And to get comparable performance on an open source local model, we really have to scale it up to something that we have to host on our supercomputing clusters, which we've done before and one can do. It really needs to be of that sort of large size to perform well. Again, I haven't found a lot of folks who are very enthusiastic about GPT OSS. I myself haven't worked with it. I just heard some people feel like they felt like it was not as good as it was promised. Mistral, we've had some better experiences with Mistral and Mixtral. Our 2025 paper uses some Mistral and Mixtral models, and some of those have some nice potential. Some of those have a different structure. The Mixtral models have a different underlying architecture than some of the others that can make them more efficient, even though they can be smaller. But again, my major concern with these local source models is, can I host them in a way that I can use the large enough models to get good performance out of them? I think that can be a challenge. Not for everyone, it depends on your resources, but you really need a lot of computing power to have really large local models running.
Okay, great. Oh, very detailed answer. Let me take advantage. I want to ask a question myself. I think actually I have multiple. First question is about kind of like a dialogue and conversation between your group and also Busby, posing some challenges to the LLM results and the Busby papers. I think you may have cited already, and the version I read was 2023 or 24, and about the problem of LLM compared to the human sample or a silicon sample versus the human sample. And specifically, there's a problem called the variance suppression. So coming to the idea that LLM is prediction based, but basically try to predict what the prompt is asking. So that means when we prompt the model to get some profiles to give the answers. So the variance will be generally smaller than the real human samples. I wonder if encounter something like that. You may have addressed in the sort of papers. Can you give us a pointer on addressing this variance suppression problem? Yeah.
Yes. I think that the Busby et al. Paper is a really good one for anyone that wants to work in silicon sampling, and I would recommend that you read it. I'm not necessarily speaking to you, Carl. I mean, in general, people I think ought to read that paper if they want to work with silicon sampling, because they raise a lot of issues, many of which we didn't consider or think about in our paper. And so I think that with respect to variance reduction, or sort of a inaccurate sensitive variance on a set of variables, I think that can be especially important if you're dealing with attitudes that sort of have strange distributions, or if you're dealing with attitudes where there's sort of a long tail, or attitudes that again, you're particularly interested with people on some part of the distribution that's not in the center. I think that is a very important consideration. So I mean, we think about this a lot, and frankly, a lot more than we did before they published their paper. I think that they really pointed out something that we hadn't considered, and that we didn't really talk much of anything about in our paper. It's helped us a lot to think about, okay, well, not just the mean correspondence, but are we getting the whole distribution? Again, in our 2025 paper, we thought more about that because we read with and engaged with the Busby et al. Paper and their way of thinking. And I think theirs is also a nice example of using multiple language models to try and make sure that it's not a function of just one particular model. Again, at the time that we did ours, there was really only GPT-3 that was the best thing that existed, and there weren't a lot of other options. And it's obviously not the space now. And I think that the Busby et al. Paper does a nice job of trying to include multiple types of language models in addition to their what I view as the more sort of substantive contribution about, well, what about variance, and what is that can often be extremely consequential, especially when we're looking at particular concepts. So I think about it a lot now. I think it's just as important as mean correspondence. I think there are perhaps some ways to address this with prompting. I don't mean that in any kind of way that's directly critical of their prompts. I think their prompts are well thought out. I've looked at them and read them. But I do think that one of the things we do when we do any kind of silicon sampling or synthetic data is we try to look not just at the mean levels, but like what is the range and the mode and the distribution. Because often, again, sometimes the language models can get stuck in ruts, so to speak, where they're only ever saying like 2 and 3 instead of the full range of numbers that are possible. And so I think we think about it a lot, and frankly, I think that anybody that wants to do any kind of simulation should also be thinking about variance as well as mean correspondence.
Great. Let me see if more questions coming from Taiwan side or from a US side. And I have another question. Actually, so I think last time we met in SPSA, I think you were working on a paper comparing different models, AI models. And did you get the work done or send somewhere? Maybe I can get that and maybe send it to you. Yeah.
That's the paper you linked to, the Lyman et al. One. It was that paper. So that was, I think we may have presented more than one thing, but the thing that I presented was this balancing large language model alignment algorithm fidelity. We used, I think, maybe 5 or 6 models in that paper, and they were, and we had both more aligned and less aligned versions of those models. And we worked in that particular one. We worked exclusively with open source models because we wanted ones that were less aligned and more aligned, and that's typically, you can't typically access that type of thing with a closed source proprietary model. So, but that work that we shared at that conference is what's now been published in this 2025 paper, the Lyman et al. One. That's the project that we shared in Puerto Rico.
That is wonderful. Yeah. Let me check again. Any questions from? Now, I have another questions on the chat. Dr. Mei Yuan, and what is the risk that LLM generated silicon samples reinforce the stereotypes? Similar to my question, yeah.
That's a very good point, and something that I think is a real danger, or can be. What is in To what extent do language models possess a rich, nuanced understanding of groups and individuals, and to what extent are they over reliant on specific stereotypes that are overgeneralizations or harmful or hurtful or socially problematic? I think the risk of this is highest for groups that are less common, right? Especially groups that are going to be less well represented in the training data that the language models come from. And so I think where I sometimes encounter this when I go to conferences and meet with other people is especially people that work in very specific linguistic contexts and that may be very low resources. Sometimes the language that linguistic people use, it's just sort of not very common, not very accessible, not well distributed across the world. But those types of linguistic contexts, I would expect to do worse. Groups that are less, again, lower percentage of the population, I expect to do worse. And what I mean by worse here is to be over reliant on stereotypes. And I think that language models they can be prone to do this. They're drawing from human constructed texts, and as a result, they reflect back at us the things that we have in our minds, and many of which are stereotypes. And so I think the degree to which this is a problem from a scientific perspective, thinking about using this as a social science tool, sort of depends on are you trying to understand people's stereotypical beliefs, or you want something different from that? So what I mean by this is, again, if we want to understand the nature of people's, for example, racial prejudices, we would want to get a sense of what those prejudices are from a language model. If instead we want a language model to be able to, for example, ask the question in a way that was appealing or understandable or relatable across a variety of groups, we would want it to behave differently. And so, I mean, I definitely think that language models have contained in them stereotypes, and they can be used to reinforce them. And what we ought to do about that, I think, depends on what we're trying to make an inference or a conclusion about in our particular application. Again, at the highest level of using them as a technological tool, I certainly think they have embedded within them lots of stereotypes and lots of prejudicial attitudes, lots of things that people have, I think, that become embedded in the language models. And I think it's important to consider that as people are thinking about their particular applications.
Great. And I do have a follow-up question, or maybe a comment too. And now you mentioned about pedagogical value, and I think nowadays we cannot deny that AI model used in the classroom and is inevitable, and one way or the other, and or some doing more, some doing less. And but I highly appreciate your bring out the workflow and for research. And do you have any papers on how to develop a workflow, or how to more factor this in the classroom setup in teaching, and so students can, generally I want to bring into what is something called AI literacy, and so otherwise then we want to see if something could be more standardized in the pedagogical setup, and the students can get generally will avoid that using it in the wrong way, or in avoiding potholes, etc. Yeah. Any suggestions? Any papers you have done?
That is a space that I don't have a lot of citations on hand about. I mean, I have my own reflections about how I approach it, but I have not encountered a lot of folks publishing on how to use it in the classroom. There's some, I know that there have been some calls recently for, I think, some special issues, maybe in PS or some other places, where they're trying to think about this from an instructional standpoint. And I actually, I'm less familiar with how, for example, the educational research, not just sort of political science, but sort of education in a proper sense, like how they're studying this. And so I'm less familiar with those citations, but I would expect that there's a lot there. I just don't have many on hand for myself. It's not, I've not encountered many political scientists or social scientists from the cognitive fields that I work in, like psychology, for example, publishing in this space, but I would guess that educational researchers are very interested in this. I think that, the that are parts of classroom in various forms, I think, have to wrestle with this now in a way that's sort of inescapable. I don't think that means it's always going to stay the way it is, but I think that it's hard to really prevent it from entering the classroom. There are ways to do it. There are ways to change the structure of exams and assignments so that it's not an accessible tool, or a tool won't help them to perform the task. But many of the things that I know for myself as an instructor, I sort of took for granted as an assessment of students' understanding, are not tools that I rely particularly much on anymore because of these developments. And so I'm not going to be as helpful about providing citations other than to say, I personally, if I was looking for this, I would look to the education space and educational research to see what they produced in this and see what, if any, work that's in there. And I'd be surprised if there wasn't any. I just have not seen much in my particular field, that is to say political science, like being published yet about that. And it could be just due to the newness of the tools. I have seen at some of our most recent conferences, like APSA, for example, in Vancouver and some other places, more recently other conferences, I've seen breakout sessions and plenary speeches about how AI in education. And so I think that our field is thinking about it, but I have not yet seen publications about it. And again, for me as an instructor, it's mostly made me rethink what are the assessments that I'm using, and are those assessments really evaluating the skills that I want my students to have? Or do I need to think about those assessments differently, restructure them, change the format, focus on some different learning outcome or objective? Like, that's how I personally have approached it. But I am interested in educational research on it and just have not yet found much published.
Okay. Yeah, maybe the next project.
Yeah.
All right. And Professor Pan, do you have any students that you would like to relay a question?
Yeah, just a follow-up question here. From the application perspective, and it shows that great potential for market research, but when it comes to the political arena, particularly the election campaigns, the success rate of language model might be subject to different contexts. Taiwan, for example, the question of how trustworthy are the political opinion polls, and the sentiment here has been going the negative direction. There might be various reasons. One of them is that more and more people do not express their preferences. So you have this side and that side, but probably like 50% that they don't express their preferences. So how does this phenomenon affect the algorithm, training data, sort of things? Yeah, can you touch upon that?
Yeah. Yes, yeah, those are really great and useful questions. And I think it is appropriate and helpful to think about how well would these tools work, or how do they work differently in different contexts with different objectives. Thinking about the political arena, there's a couple of thoughts that come to mind on that particular topic. So one of them, in a narrow way, and then I'll respond more directly to the full question, but in a narrow way, one of the things language models can help us to do, and I've seen some work by Ryan Kennedy at OSU and some other places, like is using language models as a way to embed something like an interview into a survey to help to push people to express their views more, or to try and gauge or evaluate views in a way that's deeper than just asking a single closed-ended question. Perhaps in the face of when people skip a question, or they give sort of an ambiguous response. And so from a survey methods perspective more generally, I think that language models can offer some abilities we didn't have before, to probe more deeply, to ask follow-up questions in a more flexible, useful way, to really take some of the deep understanding we can get from qualitative interviews and scale that up. And so I think in the face of some of these problems, like language models holding aside issues of representation, and synthetic example, which I could talk more about, but they give us some tools we didn't have before to try and improve what we can get out of something like a survey. With respect to like what this implies, what those things imply about synthetic sample training data, it is not easy to tell how much the language models weight various pieces of information in the training process. What I mean by this, is certainly, I think, beyond a doubt, language models have access to different public opinion polls, results, sometimes questionnaires, perhaps even raw data. It's not clear to me how much they weight or use that information relative to the other billions of documents that they have. And so I think that as sentiment around and the quality of public opinion polls changes, it certainly will have an effect on models, especially newer ones as they're developed. It's hard for me to quantify or to get a sense of the scale of that effect. Because again, the language models themselves they're being trained on billions and billions of documents. And how much that one particular document influenced them is sort of hard to assess. And so I think I'm not certain exactly how that will play out, other than, like, again, I think as public opinion shifts in various directions, like I would hope that if we want to use the language models as a representation of people's views, that it would pick up on those changes as the models get developed, released. And obviously, at some point, these language models, the training process is sort of fixed in time until they're updated, and so we have some limitations in terms of the trends that they can observe. But I do also think that language models can project forward, at least in a limited way. And some of the most interesting questions with them as representations is to say, well, do they give us a sense of what changes might happen, or do they give us some clues about shifts that were on the horizon that perhaps not obvious to us? I think there's some ways to use them or think about them as tools in that sense too. So I think that in the political space, in the context I know best is the United States. That's where my work is done. In the United States, there's some very strong predictors of political behavior that are really clear signals, like things like the party you belong to and your political ideology. And given the strength of those factors, like I think in the U.S., the political realm can be one of the easier ones to use language models to simulate, because we have a lot of very strong signals. In other electoral systems that have different dynamics, that's not always going to be the case. And so I think when wanting to use it as a representation of political views in various countries, one should think about the different factors that influence politics in that space and how stable those factors are. I think in places with more stable political trends, the language models would be better. In places with more instability or more recent changes, I would expect the language model to do worse. So, I mean, that's sort of a scattershot answer to that set of questions. And if I've overlooked or neglected to respond to one of them, please ask it again. I'm happy to sort of dig into that. But I think that's a really important question to consider, both the nature of politics versus some other context, and then also politics in a particular place at a particular time is important to integrate into this validation verification process.
Great answer. I think I want to have a follow-up question, but before I do that, Dr. Marian Stewart has a hand up, and hi, Marian, and can you speak up, or you want to? Yeah, please go ahead. And
Ethan, hello. I have a
hi.
question, or possibly two
Yes.
questions that tailgate on the one that was just asked, and that is the compatibility or incompatibility of large language models and AI with what we think of as being traditional survey research. Survey research is my area, and as you probably know, because I noticed on your bio sketch, you have a background something in that too, particularly psychology. Survey research has been increasingly bedeviled by response rate problems people don't want to answer, or response quality problems, referring back to the previous question, superficiality of response. People aren't revealing true preferences, get response cutoff. Do I understand, the question is, do I understand you correctly then, that the LLM and AI have the potential to not substitute for, but certainly complement the conduct of survey research in a way that might help boost response rate and response quality?
I definitely think it has that potential. I think that, like all areas that, there are various ways to approach that. The particular method that would be best, I think, is open to exploration. But I do think that there's a number of ways, and I can articulate some specifics here in a second, but I think that there's a number of ways in which LLMs and this type of generative AI can complement and really augment traditional survey methods research. I'm not of the mind. So, as a sort of aside, when we first published the 2023 paper, I did a lot of interviews with some public opinion organizations, including some in Europe, that were sort of very direct about, do you think this means we don't need to do surveys anymore? And my answer to that question was always unequivocally no. And some of that may just represent my own sort of bias as someone that's done a lot of survey research myself. But I do think that there's always going to be a need for some kind of validation of anything we want to do. So even if, and I'll come back to the augmentation point, but even if we went all in on the silicon sampling and said, like, we just want to mostly do this and really not do much of public opinion research directly anymore, I would always have a lot of concerns about the need we have to validate and to verify how language models are operating in our context in a continual, ongoing way.
Yeah.
And I think in the absence of public opinion data, that's going to become increasingly hard in the public opinion space. With respect to like how it could be used to augment, I think that there's a number of really powerful, interesting applications. So some of this have to do with I would categorize them in two camps. Some of them are improving the survey tools as they're administered. Like, so how do you add to a survey that's AI empowered and let you do important, helpful things? And I'll give some examples there. And the other camp I would say is, what do you do after the survey is collected? What can you do to augment the data that existed from the survey using some AI tools? And so in the former camp, I think language models have the capacity, for example, to ask open-ended follow-up questions based on earlier questions, to probe when people skip questions. I think there's certainly ways to use them to pilot or sort of try and evaluate the successfulness of different messaging or incentive strategies or outreach strategies, recruitment processes. I think it has a lot of capacity to allow us to do things inside of surveys we couldn't do before. For example, there's a researcher in Columbia, his name is Jamil Velez, that's doing a lot of really interesting work saying, well, let's sort of take people's open-ended preferred policies in Congress and then sort of extract that from using a language model and use a language model to map that on to actual policies that Congress has considered, and then ask a series of follow-up questions to the respondent of their sort of closest preferred congressional policy. A thing that would be essentially impossible prior to the advent of these tools, because that's what these multiple summarization, extraction, mapping steps that weren't possible with other techniques. And others, again, are using them more as a way to do something like a qualitative interview inside of a sort of large N survey. Again, something that was not possible to do prior in a dynamic live kind of a way. And so I think there's lots of ways to try and use it to augment the data collection. From the side of after the data are collected, again, there's a number of people who are trying to explore what possibilities do language models offer as substitutes, alternatives, or for sort of complements to things like data imputation, or missing data across waves. Does this change the way the number of questions we need to ask, or can we randomize people to a larger set of smaller questions and then use a language model to fill in a more efficient way than we've been able to do with other tools? And so I think there's a lot of really interesting and important possibilities and a lot of potential. And my only suggestion to those working in the space is that I think all the things that I've talked about briefly tonight about like validation and inferences, those certainly apply in those applications too. Thinking about how will we know if we're going to use it for data imputation, for example, that it's done that successfully. Yeah.
Ethan, is there a publicly available site on some of these possibilities or potentials that you have mentioned?
Yeah, let me see. Yeah, let me see if I can find some for. I'll put one in for some of Jamil Velez's work. I happen to have a different paper open on my computer that has that. This is one of the references for him. For data imputation, there is as well. Let me see if I can find. There are some published works on language models.
Well, in the event that others might have some questions, perhaps if you have a few minutes a little bit later after the colloquium, you might send a couple of these suggestions to Carl, and he could send them to the rest of us.
Yeah, I can definitely do that. It's probably
certainly I put together a collection. Yeah.
That would be very helpful, Ethan. Thank you.
Yeah, and there's lots of really interesting and exciting stuff going on. And it's probably more efficient for me to send some stuff to Carl and make you sit here while I search through Google Scholar on my computer. But
That's great. Thank you. That would be a big help.
Yep.
Yeah, one way I'm doing it is to check into citations of your 2023 papers. I think they can look through those. Yeah, and I can name a few already. John Elder and also Sun Elder, and also of course Busby Elder. These are examples of citing a paper and how they could be extended to human samples. Now, I think let me see if I have more hands. And Marianne, please feel free to ask a follow-up question. And if you think of another one down the road, and on the Taiwan side, I want to make sure that your students any questions, or maybe then I can relay that here.
Okay, here's one. Well, it says that the current operation of polling agencies commonly combines traditional telephone surveys with text mining or sentiment analysis in order to complement each other. So do you think that incorporating silicon samples would be the future directions, because they have the telephone surveys, of which kind of a lack of some kind of information, and then use the text mining or sentiment analysis to complement that part. And now we have silicon samples as another part of the combination. So what do you think of this kind of combinations to do the surveys or opinion polls?
Yeah, so first at a descriptive level, I know that survey vendors are doing this already. Like, I mean, beyond just like my guesses, like I've had some conversations with different polling firms about this, and I know that many of them are either integrating it into what they deliver to their customers, or they're planning to offer it as a part of what they produce. So to say, well, we can give you a sample of 500 people and also augment that with another 1,000 simulations in various ways. And so I think it's very attractive to many of these firms that work in the polling space because of its much lower cost to do that. I think that my concern, I suppose, with that is I think that's mostly being driven by financial considerations and marketing considerations, and far less about like accuracy and validation. And so I personally, if I was in a place where somebody offered me such a product and said like, well, we're going to give you, 300 or 400 people and that are real human responses, and instead of simulated responses, I would have lots of questions for them about, well, what is your process for developing these simulations, and how do you know that they are going to be useful or that they're valid reflections of what people would have said? And I'm not saying there's no answers to those questions, or that all the firms working in the space don't think carefully about that, but I also think that because of the dramatically lower cost of replicating these things with silicon samples, that's driving a lot of the interest in it, as opposed to like sort of real gains in validity and other types of differential knowledge. Like, and to give you a sense of the scale, like our replication efforts using our 2023 paper, where we were sort of replicating these surveys, I mean, they probably all in total cost us less than $1,000. And we're talking about replicating surveys that are like hundreds of thousands of US dollars to run. And so I think there's really clear efficiency gains, but I want to know a lot more about like what is being done to make sure that these things that are cheap are valid. And I'm not saying I'm not saying nobody could convince me, but I am saying I'm a little concerned that a lot of the moves towards it that I've seen and discussions that I've had with some of these organizations are being driven mostly by profits, which is not bad. Like, but I want to know more about like, well, how much do you know that we can trust these things, and like what's your process been like to make sure this is a valid exercise? And I know less about that, but I do think in a narrow way, beyond my sort of just opinion about this, I think that is a good question, and it is already being developed, if not already offered. So I think it is definitely a place that many organizations.
Yeah, but because I asked it because the other day I ran across a guy that actually is from a part of our friends, and then he's running a polling agency, a company. So he's been talking about that too. So he said that this is the developing. There's a future direction. And then I asked him, well, and how trustworthy is that? And then are you going to use this to, substitute or is that? He said that it's impossible because it's still developing, but it's a perspective though. It's very promising, but it's not yet. Yeah, it's not yet. And considering the cost, like you said, $1,000, and you can do the work, and that's very attractive, right? If that is valid and reliable, and of course they're going to move toward that direction, though. Yeah.
Yeah.
Okay, Carl. I think there's.
Sorry, I mute myself. Yeah. Do I have more questions from either side? Otherwise, of course I have a few other questions, and maybe I can follow up with your earlier questions. I think you mentioned about the political context, and the Taiwan case is what I'm studying also, and has to used to be very similar to the American context, and with basically like a presidential system, and except that it added what called a PR component in the Congress, allowing the third party to emerge, so making it more difficult. So, however, I think that I think this is still a lot more value to replicate your 2023 works, and I see your follow-up work and how much that could be done in supplementing or augmenting the current way of polling. So particularly something we're working on is how much we can deal with those responses that could be challenged, such as some responses could be made up, or some could be non-response, or some could be not represented in real value, or particularly, and we are interested in some part of the population is not easily predictable. So, for example, I think last time we talked about the Pennsylvania, over 100 polls, and still they cannot get to the right answer, and still a lot of variance, and compared to Michigan and then Minnesota. Those. So tell us a little bit your opinion in the future, and in helping with the predictability of this polls, or particularly, and how much we can narrow the variance and get to improve the way the public opinion polls or election polls, and at least not to make so much mistakes, and like last time, like 2024. Yeah.
Yeah, and there's been some really interesting work by Ray Dutch and Roberto Cerna from
Roberto.
Yeah, Roberto.
Yeah. Yeah.
And using
Awesome.
trying to and they have a newly published paper, I think, which I can dig up and send with the other things that I send you. And sort of trying to think about how can we use language models to extract survey-like data from things that aren't surveys. So they particularly focus on social media posts and things like that. But I think there's, again, some potential to say, well, can we try to take the information we have from people in one setting and then use that information to just either simulate, supplement, add to whatever a traditional survey, or compare to a traditional survey. And they're big believers in this. I think they've got some very promising publications about saying, like, look, we're trying to say, look, we don't need to do, we can do a set of studies that don't require survey, and that we can still get similar knowledge, especially in the face of these challenges that we have with collecting survey data. It is a sort of a growing concern without a lot of very clear solutions about the diminishing quality in many places of surveys, and sort of some obvious misses that have happened. I don't say obvious in the sense that the solutions are obvious, but very clear misses. Like, and so again, one approach would be to try to use language models to come up with survey-like responses using other types of data, whether it's social media posts or something else that the language models can process, and then use to extract something like a survey. There is also a tension, I think, well, essentially, survey researchers, including myself, often have paradox where like we want to understand better a group that's not well represented, and again, I'll make this concrete with an example. And so we'd like to be able to go to a language model to help us fill in more respondents, so to speak, in those categories. The tension for me comes from those also tend to be the groups that are not well represented in the training data for the language models.
Indeed, yeah.
And so I think while the language model can certainly give a response, I think there are lots of questions about like, well, how accurate or distorted is that picture? So again, an example that I think a lot about in the United States is that generally speaking, survey researchers, at least my sense of them, they have more difficulty including Trump approving Republicans in their polls than other kinds of Republicans and the Democrats. And I don't necessarily mean based on the topic. I just mean there seems to be some skepticism of engaging as a participant in surveys among that population. And we're sort of always trying to sort of push ourselves and say, well, look, we have the right kind of Republican in the sample to really understand the whole population, or what can we do to recruit or reach out to those folks and make them feel more heard, seen, whatever, or accepting of this enterprise, like. So we could think about, could we use a language model to try and represent that particular group if it's absent? One thing we could do, because of the low cost, is you can imagine doing a bunch where you make some assumptions about those groups being dramatically different from the ones you've observed or very similar to the ones you've observed, and trying to put some inferential bounds on your estimates. And in other words, like if we assume that the Republicans, for example, in the U.S. context we have in our survey, are very, very different from Republicans at large, what might we have observed? You can use a language model to try and fill in very different types of responses from Republicans, and try and set some bounds around the error you might have. And that's not dissimilar from some existing approaches in political science about civil uncertainty bounds and things like that. Like, but because you can do the language model simulation so rapidly and for a relatively low cost, you can imagine like rerunning simulations with a different set of instructions that sort of really try and get to represent the most extreme, most distant version of Republicans from the one that's included in the survey. So that I think is a possibility that would allow you to sort of to keep in mind the possibility that the language models are going to poorly represent these excluded groups or these underrepresented groups. But again, I think that there's some possibilities in terms of using the language models to come up with something like survey data from other sources, as well as to try and fill in missing gaps from populations. But I worry a lot about validation for those underrepresented groups, about trying to get a sense about if we don't have a lot of empirical sort of touchstones, so to speak, how will we know how well it worked? But I think there's ways to at least creatively approach it and to think carefully about it. And I think this adds another tool beyond the ones that we've had before.
Yes, exactly. Yeah. Excellent answer. And do we have more questions for Dr. Busby?
Yeah, there is one more here.
Either side? Yeah, go ahead.
One more here. Yeah. I'm not sure that you have touched upon these issues, but here the question is about the temporal issue of the data, because as we said that the human attitudes evolves over time, and then probably it evolves very fast, maybe just during a couple of weeks or maybe even within a month, and they can change. So how do you design or continue to research on that in considering to simulate the temporal shift in public opinions or the model? Yeah. So
that's also really useful and important question. So let me give a very narrow answer first, and then sort of expand more with some of my other thoughts. But like, very narrowly, one of the things that we did in the 2023 paper was we looked at the correspondence in simulations that were focused on time points that were included in the training data, so 2012 and 2016, as well as projecting forward to points that were not in the training data. So in this particular case, in the US was like the 2020 election. And at the time, the model we were using, the GPT-3 model, it was the training period for that finished in like 2018 or something like that. And so we wanted to get a sense about, is it strictly bound by that? We found very high levels of correspondence. Again, I'll have some caveats to this in a minute, but we found some high levels of correspondence for all of those years, for 2012, 2016, and 2020, which suggests some ability of the language model to project forward that some of what they're doing is starting to understand some patterns in human thought and behavior that are not just about one moment at a time. The caveats I want to add to that is that, clearly we looked at one very proximate point in the future. We didn't look at like 2060. We looked at a couple of years later. And the dynamics, I mean, certainly, in the US, and especially related to the 2020 election, that COVID was certainly not a part of anything that was in the 2018 training data. So that's an unusual event that I think most people would not have predicted. But it's, again, not that different in terms of the election dynamics. And so my general thinking about the temporal nature of it is that I expect that the simulations will be better when we're talking about more gradual changes or changes that are simply a matter of degree instead of like fundamental type or quality. And that when something happens that's extremely disruptive and unexpected, it's probably going to be more challenging for language models to represent that. Now, all the language models I'm aware of are being constantly developed and updated, and the training data are being updated and sort of refined. So there certainly are newer versions, for example, of models where training data goes far past what we showed in our 2023 paper with that GPT-3 model. So again, one approach to this is to try and one could, for example, try to use, especially some open source ones that were trained before and after some really sort of disjuncture type event, whether that's something like COVID or something else that's unexpected. And we could empirically evaluate this, right, and say sort of how well does a model do before and after some event, before and after some update to the training data. I generally think that language models have more capacity for this than we would think. That is to say, I think it's true that language models are not simply parroting information that they've digested and are instead sort of developing more complex constructions and ideas about how people think and operate that go beyond just restating things that have already occurred. I don't necessarily think that means this is infinite, that this capacity is unbounded, but I do think it's doing something more, it's representing people in a more fundamental way than just simply telling us things that have already been said. And so I think there's some potential here, but I believe, or I think the challenge would be greater when you're dealing with events that are very unpredictable, or there weren't a lot of signs that something was going to happen. And it will probably do better with more gradual over time changes. Again, to use our example, the elections in 2020 certainly were different than 2016, but a lot of the underlying connections between people's attitudes and their preferences for political candidates were largely the same. And many of the things that you would have guessed would operate in 2016 were probably still at play in 2020. Not all of them. I'm not trying to say nothing changed, but many things were similar. And so that is perhaps a reason why it worked well for us and might not, if there's some really fundamental sort of shift. And those things happen, and they're important. And in some sense, they're some of the most important things to study in politics are these unexpected things that have unexpected and very large consequences. And so I think there's some capacity there, but I would expect it to be worse for really dramatic changes. And I also think there's some creative ways to try and approach this empirically that I have yet to see demonstrated, but somebody could explore and really try and probe the limits, so to speak.
Okay, thank you.
All right. Now we have user.
Ethan,
Yeah, go ahead, Marianne. Yeah, you have more questions?
Excuse me, I have two comments, Ethan, just for further consideration with the way forward. It seems to me that when we're thinking about whether the large language models need to be adjusted, that we need to have a theory of context. That is a context in which attitudinal change is likely to occur or when it's less likely to occur. And there have been notable periods in the US where stability was the norm rather than dynamics, and vice versa. So we can't simply say every election is another opportunity to adjust a an LLM. That may or may not be so, but a theory of time and attitude formation needs to be brought in here. A second comment, and I'm just thinking more about what you're saying, is one area, if we're talking about bashful respondents or respondents who don't want to admit their preferences or respondents who we can't find, area where LLM can be potentially really useful is at the subnational level in a federal system. Particularly, we're talking about the United States. We can get pretty good national level data from surveys from NORC and NORC and YouGov, et cetera. But what is a real problem is getting good attitudinal behavioral self-report data at the local level. And there's only one study I know of that is doing that right now at an exorbitant price with NORC, and that's Houston. So we may tap your brain a little bit more about shifting downwards at the level of the federal system to boost and to boost response. Thanks for listening again, Ethan.
Yep. Yeah, I think those are really promising possibilities. And I mean, I definitely think that any, and this is a part of what we describe in the commentary paper and how we think about this is any attempt to use language model that's more grounded in theories that of what we know or well-developed theories in the social sciences about how people think and behave are going to be better uses of language models than those that sort of ignore or set aside those considerations. And so I definitely think that what you bring about change and theories of change and stability are important and useful if we want to think about this. And I think you're absolutely right about the exorbitant cost of those types of subnational data in the U.S., despite their importance given our electoral system. And I know, for example, that I believe in some of Roberto's work with Ray Dutch, they found a astonishingly high level of correspondence at not just the national level, but also the state level. And so I think that the types of tools we're talking about have some potential there. They're not always going to perform well. I'm not promising that. But I think that some of these newer applications that really have their eye on that, given that the stakes and the gains there are potentially quite high.
Yeah, let me try to also look for the paper you are referring to. The one I gave is his archive paper. I think Roberto's archive. I think that I can look for the one that he co-authored Dutch. I think this is the package, and so
Yeah,
that is.
I put a link, Carl, to one of their articles published in 2024 about the 2024 election. I found it in PS. And so that is an example. I think Ray and Roberto are still working on this, and I expect they have other things in the works too.
Okay, yeah, great. Thank you for providing the link. Now, thank you, Marian, for the comment too. And any more questions, or let me see another hand up here. Fang Yu, and can you speak up? Fang Yu, go ahead. Fang Yu, do you have a question? Do you have a hand up? Okay. Oh, somehow your mic is mute, and it's muted. All right, and let's wait a little bit. Maybe she's unmuting herself, and if you are unable to use the mic, you can type out the questions in the chat box. And Shantran can relay the question to. I think it's approaching at 10:40 now, and now maybe I can ask one more question. Have someone ask one more question? Otherwise, I can use the opportunity. And Peter, if you have one more question, or maybe we can one more question on the US side, then we will wrap up and then talk about the next event. Peter, do you have any additional questions from your side?
Not for now. It's yours.
Okay, then I will ask my question if Fang Yu still not taking the mic on. Now, so this is a question I also look into myself about comparing the agent-based or generally agentic AI question versus LLM-based research. So some agent-based models and claim that they can do much better prediction. But my question is not about specifically getting the best prediction and how much we can use agentic AI to combine with LLM to see how much we can improve the way we gauge the public opinion. I would not say that I predict exactly, and like Roberto and Ray did in the paper. I'm generally more interested how much we can use agentic AI and also LLM to better gauge, better understand the public opinion. What's your view and what's your you're doing research and what's your view on this? Yeah.
So there is, as a small note to start, there are a group of people working to really try and revisit or resurrect in some ways the sort of older literatures on agent-based modeling and really infuse them with language models so that you can observe and document things that are richer than what we could have observed with the more limited agent-based modeling approaches, which are fairly limited in terms of the things, the parameters you can control, the types of behaviors that you could model. They were useful and I think led to a lot of nice insights, but they were limited. I think some people have tried to bring sort of new air into that, new life into that by sort of using agent-based models that are sort of linked by or really empowered by LLMs. And I think the work I've seen in that particular space is still ongoing. I haven't seen it published yet, but I know of 2 or 3 groups of people working in different ways to try to again do something more akin to agent-based models, but to represent other types of behaviors and attitudes that go beyond just survey self-reports, like they document the kinds of things that really agent-based models were after originally anyway in a richer way. So I think there's certainly some potential there. I think some of the places that I see some big potential is trying to sort of document not just people's public opinion or their opinions or attitudes and again surveys. I think there's a lot of potential there. But I also think it really scratches the surface in the sense of like we could start to explore like how people deliberate in bodies, for example. We could start to explore things like different types of discussion. We can try to simulate or have an AI agent be a part of a conversation or one part of a conversation. There's been some really great work by Chris Sommerfeld and some others out of connected to Google DeepMind about like using AI agents as part of like deliberations to help people deliberate better and to sort of really synthesize some common parts, some common sources of agreement that are not obvious on the surface. Like, and so that's an example about maybe trying to interject something or sort of improve public opinion in some way. But I think there's a lot of really promising applications. Really trying to do more than just the single responses to a smaller set of questions. I also think that some of the really ambitious work in terms of the simulations of public opinion, I've tried to step back and say, well, what if rather than just using these pretty stylized backstories that we use, which are again sort of an amalgamation of survey questions, what if we sort of, and one particular group spent hundreds of thousands of dollars to do a set of like 1,000 or 2,000 really hour-long interviews with people, and then use those transcripts to construct really rich representations of people with language models, and try and generate more all-purpose, really nuanced, really complex synthetic representations of people. And again, that too, I think that work is ongoing and not published, but they're trying to really say, well, what happens or what are the gains from not just using the simple stylized backstories that we did when we do synthetic data, but what if we give it a really rich understanding of someone? Could it do a lot better? And I think there's a lot of potential there. I mean, again, if you have the resources to conduct 2,000 1-hour interviews, I think there's a lot of things you could do with that. And again, they're getting, I think, some nice results about saying, well, if we give sort of more free-flowing narrative, more in-depth discussions from people, the language models can do better at representing them and people with thought processes like them. And so those are some of the areas I think that the synthetic data and the silicon sampling areas are going on. Can we represent things that are more complex than just surveys, different types of interactions, different types of behavior, different types of deliberations? And then in the space of still representing attitudes, I think there is a push to say, well, are there ways to give it a richer understanding of somebody's experiences, ideas, sense of self, etc., that would improve the way it could be used in a variety of ways? And the objective there is not as narrow as ours. Ours was like, how can we get it to represent a specific set of attitudes on a specific topic? And this is far more general purpose to say, well can we come up with a way to construct these synthetic agents that can answer a whole host of questions about a whole host of things, sort of in a much more detailed and nuanced way. Those are some of my thoughts about where I think a lot of the newer areas are going. Again, much of that is still ongoing, but I think there are a lot of people trying to push those boundaries in a way to go really far beyond what we did, to explore in what I think are some pretty exciting and ways, but that also have a set of challenges. And I think they're very aggressively and creatively trying to address those, and doing a lot of really interesting work. Does that answer your question, Carl?
Yeah, that's the direction. That is something I recently explored also. And generally, the agent-based model is one thing, but I'm more interested in agentic AI, training an agent and more localized your model. I think, but you addressed it earlier in the talk. I think, maybe we can. Down the road, we can invite you back maybe for another event to talk another. This is another big topic, and so this is something I'm planning. Maybe we can do more, and this one is really too short, and for one section. Hopefully, in future we can bring you back in person and to do more in-person workshop and also talks too. Now, I think this is about time, and. Peter, I think, do you have any wrap-up comments or remarks or a reminder for students? I'm going to post our next event link about our own Professor Mei Yuan to give a talk, but it will be in November. Yeah, go ahead, Peter.
Yeah. I just want to thank you all for coming up here today, and thank you especially for Ethan. Yeah, this is one of the topics, and actually, this is a quite new area for most of us here. So I want to thank you for that, and also for all the participant audiences. Thank you for staying with us tonight or this morning.
Yeah.
And then I want to remind you that actually, Professor Mei Yuan is here too. And then the next, our next colloquium will be. She will be our special guest next month. That will be on November the 13th, United States time, and then the 14th here in Taiwan. So please stay tuned, and looking forward to it. Yep, Carl.
All right, I post a link if you like to click on it for registration. And all right, I think at this point it's getting late, and I cannot say thank you enough, Ethan, and give us a really eye-opening talk and a lot of great citations, also the links that were references to. And I think I want to say thank you and to wrap up and to conclude, thank you for joining us, and look forward to seeing you in the next event, which is November 13th. And thank you again, Ethan. You have a good night, and look forward to crossing paths with you and particularly Southern again and New Orleans.
Yeah.
All right.
Thank you very much.
Thank you.
Thank you.
Bye.
Bye. Bye.
Okay, just a quick wrap up. So.